So now, in this video, we have a trim pot over here that we can use to adjust the brightness of the LED. But what is important, I'm going to dim the lamp so the LED looks brighter. It looks brighter in person. But in any case, we have the LED there. Its brightness depends on the trim pot right there. We're working with 12 volts. And we have a 1000 ohm resistor. So it's the voltage we set at the base and the resistor that determine the voltage. So we'll talk about that really quick. We have the base to emitter of the NPN bipolar junction transistor. I'm using a 2N3904. That drops about 0.6 volts from base to emitter right there. So if we set the trim pot to 1.6 volts, at least what makes it to the base right there, we will lose about 0.6 volts. That will put about 1 volt across the resistor there. The transistor will conduct as well as it needs to maintain that voltage. 1000 ohm resistor, put 1 volt across it, you'll get 1 milliamp of current, because there's 1 milliamp of current that will flow for every volt that you put across the 1000 ohm resistor. A milliamp is 1/1000th of an amp. So you do the math in amps and so on. But in any case, if we set 5 volts, 5.6 volts, approximately to the base right there, we'll have about 5 volts across the 1K resistor, and about 5 milliamps of current will flow through. So it doesn't matter what the load is. In this case, we have the LED, as long as we have the voltage that's going to go across the resistor, plus whatever the voltage is that the load needs to pass that current. Red LED, it has a fixed voltage. When it's lit up, it's forward biased, and it's got about 2 volts across it. So at least with the LED, our maximum current is going to be somewhere around like 10 milliamps of current. With no load, we could probably get closer to 12, and so on. As you add more load, you're going to have less current that you can get to flow through, because ultimately you'll get less current that can go across the 1K resistor. Now we do want this resistor here, if we go all the way to the positive supply right there, that's a much easier path for current to flow than any load. So that will just build up the voltage across the resistor right there, and the load will just have power cut off to it completely. So we want to be able to set a voltage, but not be able to have enough current to flow through to overpower what the load needs. The current needs to flow through the load ultimately. So now we got the multimeter. It's always safe to set the meter to measure voltage right there. And as long as you don't exceed the voltage limits of the meter, and we don't move the red probe for anything other than high current right there. So don't have to do any more for this particular multimeter that we're going to measure voltage with. So we have these alligator clips right there, that I'm going to clip to the probe and plug into the board. That will help, avoiding pushing on components, which can alter things. And also, my hands aren't in the way as much and stuff. So we will clip that there. So first, let's look at the supply voltage. We're at the negative rail. Make sure this probe doesn't touch anything. That's kind of where the danger comes in measuring voltage, if you accidentally touch the probe to something you don't want to, when you're also touching a different voltage level. So there we go. We got about 12 volts at the supply rail right there. So I want about 5 milliamps of current for whatever reason. So one way we can do that is just come look at the resistor. It looks like we're already pretty close to 5 volts across that 1000 ohm resistor. So it's the voltage across the resistor and its resistance value. So I'm just going to put this up just slightly right there till we get to 5 volts. So that's probably the best way. It doesn't have to be 100% spot on. I'll try to get just a speck above 5, but there we go. So this is probably the best way to do it, and I didn't expect to get that close, but that's pretty good. Now we're going to go to the base of the transistor. You can see it's about between 0.6, 0.7 volts higher right there. So you could also use this method, measure the voltage at the base. Just remember that emitter resistor is going to have about 0.6, 0.7 volts less approximately. So now we are going to measure current. So I'm going to pluck both of these right now, and we got to be careful measuring current. We're going to wait to set the meter to measure current until we're pretty much ready to go. So we got that there. Now I'm going to set this to measure current, it's going to be in the milliamp range, about 5 milliamps, as we saw before. And so I can measure up to, I believe, 600 milliamps of current. Well, it says milliamps. Again, don't have to move the red probe for anything other than high current. We had to open up the circuit. When we measure current, it has to go through the meter as well as everything else it's going to go through. So I go below, one spot below that positive supply right there. That positive supply is not connected to anything anymore. We are connected to the collector of the transistor. And again, we'll measure the current going through the red LED, and it's pretty spot on, 5 milliamps of current as we expected. Now we can bypass the LED, and this is when we really want to make sure we got everything wired up properly, because now I'm going to put this to the rail. And the power supply, you can see it's practically the exact same amount of current. It will be just a speck different. That's to be expected. But we're not going through the LED anymore. We're just going to the collector right there. And you know, just in case I accidentally miswired something, I set a maximum current of 30 milliamps of current right here. So that's more than I'd want to put through the red LED, but probably won't destroy it. Might shorten its life though. So yeah, we saw that we got about 5 milliamps of current through the red LED. The transistor and that 1K resistor right there. And now I'm going to grab the blue LED. We saw how to adjust that. And it's not part of the circuit yet, but when I make it part of the circuit, we should have practically the same amount of current flowing. And the blue LED is washing out the red LED because it's just naturally brighter at a certain amount of current. So usually I put closer to 15 milliamps of current, usually a little bit lower, through the red LED, and then about 2 milliamps of current through the blue LED, and they become, you know, about the same brightness right there. That's kind of hurting my eyes. So as long as we have enough supply voltage, so we need 5 volts across that resistor. Blue LED is dropping 3 volts. Red LED is dropping 2 volts. So right now we got about 5 volts. 5 volts across the 1K resistor. 5 volts across the 2 LEDs is a total of 10 volts. So we're really getting basically to our maximum. If I add a green LED, that should definitely exceed the total voltage that we have to work with, 12 volts, because there should be 3, 6, and then 2 more, 8, plus 5 should be about, I think that's 14 volts, 13, 14 volts, whatever it is, more than 12. And there you can see, now we don't have enough voltage anymore to provide 5 milliamps of current. So you can't exceed the load, but as long as you got either, yeah, I don't want to go there, I want to go to the power supply. You can have no load right there, or a light load, doesn't matter. That's what a current source does. It sets a current regardless of the load, as long as you got enough supply voltage. That's the main thing. Normally, you want to make sure you have enough supply voltage, and so the voltage will remain steady as long as you don't demand too much current from the voltage source. So in this case, if we asked for more than 30 milliamps of current, it would actually lower how much voltage it provides in order to maintain that 30 milliamps of current, give the circuit less voltage than it wants to exceed 30 milliamps. And again, it's not super dangerous, but the most dangerous thing you can pretty much do is have the meter set to measure current and then try to measure voltage. So you don't want to do that, because the voltage won't be limited unless you limit with the power supply, like I showed here. So if it has an on-off button, set it to voltage and turn it off. You know, it's safe to measure voltage at any time as long as you don't exceed the voltage rating. This one has an off setting though. I gotta set it to off anyways, but I like to just do that reminder, get it off of measuring current, even if you can turn it off without getting it off measuring current. You don't want to accidentally measure something when it's set to current if measuring current isn't your intention. So, in any case, that's it. Hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out links down below. They all help out a lot. I'll see you in the next video.